All right, all you math lovers, here we go with an example of what we call a linear decreasing pattern. If we look at these numbers, 77, 73, 69, 65, they are decreasing. They're getting smaller. But the trick is they're getting smaller by the same amount, so that means they're linear. If we were to make a graph of these numbers, it would make a straight line going down. So if we think about this as a pattern rule in words, we start at 77 and then we subtract. So we're decreasing. How much are we subtracting? Looks like we're subtracting 4 each time. Okay. So the main part is I am subtracting by the same amount each time. So I'm decreasing. This is a linear decreasing pattern. A lot of kids have trouble with these decreasing patterns for a couple of reasons. One is coming up with the algebraic expression. We can follow the same steps, but it's a slight difference that I'm going to show you in this video. But also, these numbers, if I keep going in this pattern, eventually are going to get into negative values. It's going to drop below 0. Makes sense because it's decreasing. The numbers keep getting smaller. So once we get into the negative numbers, it messes some kids up. We've learned about integers, but still it's a new concept in grade 7, so we have a bit of a hard time when the patterns decrease and once this pattern gets into a negative value. So let's start first of all. The first thing we want to do is find out what the 10th number of this pattern is, and usually with just going up to the 10th number, we can easily do that by extending a chart. So let's just make ourselves a T-chart here. First, second, third, and fourth term numbers. I want to remember that the term numbers are where my n comes from, if I make an expression, which I'm going to. And my term value are each of the numbers in the pattern itself. So the first number in the pattern is 77. The second number, actually I'm going to just back up here for a second. You'll see why in a minute. I'm going to just give myself a little room at the top of this pattern, or the top of this T-chart. And you'll see why in just a minute. So we start at 77, and we go down 4 each time. There we go. So instead of adding a number each time, the decreasing patterns subtract by the same amount each time. So in this case, it's 4. Could be any number. So right now, it's really similar to when we did the growing patterns. What the difference is we're subtracting. The numbers are getting smaller. But for me to find the 10th number of this pattern, most kids are comfortable just extending the chart. Now when we're subtracting, I have to be careful that I'm subtracting correctly, so I'm going to just keep going down by 4. So we have 61 next. 4 less than that should be 57. Keep going, 53. 49. 45. And 41. So here we go. The 10th number in the pattern is 41. No big deal. Easy enough to extend up to 10 in the chart. But we also want to be able to come up with the algebraic expression for this. The expression that's going to calculate every number in the pattern, any number that I want. Okay. So I'm going to start the same way I did with a linear growing pattern. I look at figuring out how can I get n into this expression. When we had a growing pattern, if this was going up by 4 each time, the expression would start with 4n. if it's a decreasing pattern, it's still going to have 4n in it. But the difference is I'm going to take away multiples of 4. Every number is getting smaller by another 4 each time. So if I look at this, I've got 1 4 smaller. If I start from here and go to the third term value, I have two 4s. So 8 difference there, 12 difference there. So there are multiples of 4 in this pattern. It's just that I'm taking them away. The trick to this is I want to know what did I start at to take away 4s from. Okay, and a lot of kids instantly think I start at 77. Well, that's true. The pattern starts at 77, but 77 in here is not going to get me the correct expression. So here's what I want to do. Again, I'm going to check the first number in the pattern. See what I can get. If I have some number to take away 4n, so 4 times 1, because 1 is the number I'm going to use for n for the first number of the pattern. Well, what number can I take 4 away from and get 77? Because 77 is the first number of the pattern. So here it takes a little bit of guess and check, or a little bit of intuition to figure out what number belongs here. So some number, it's going to be an equal sign here. Some number take away 4 gives me 77. Well, really, this number is just 4 more than 77, so it's 81. So what that means is my expression needs to say I start from 81 and I keep subtracting multiples of 4. Another way to think about that, and here's why I made some room up here. If I went one more up in this pattern, I'd have 81 here. It's really the zero term number. If there are no n's, 0 n's here, I have an 81. I could go backwards into negative numbers if I want to, but a lot of kids are just going to take this 77 and plunk it in here in the expression, but that's not correct. I want to know what number can I start taking multiples of 4 away from and calculate every number in this pattern. So this is how I figured out that 81 belongs here. Let me just clean that up a little bit. We've got 81 minus 4n as our expression. I came up with the 81 because I had to figure out, well, what number can I take 4 away from to get 77, which would be the very first term in the pattern. Well, that number is 81. So let's keep going, checking our next numbers in the pattern. Let's check the second one. And I'm going to use my expression. So it should be 81 minus 4 times 2, because n is 2. That is 81 minus 8. 81 take away 8 is 73. Got it. Sweet. If it works for the third one, then we're good to go. Start with 81 again. Take away 4 times 3 for the third number in the pattern. 81 take away 12 is 69. Bingo. Got it. So what that tells me is this is the correct expression. I can calculate any term value that I want to by taking 81 and subtracting 4 times the term number n. Here we go. There's our expression. Awesome. This is the trickier version because of how to set up the expression in the first place. Okay, so hopefully I did a good job explaining that. I can keep extending the chart, but again, we want these expressions so that we don't have to, and we can just calculate whatever we want. And I think we were asked to find the 15th term value. Okay, so take 81, take away 4 times 15. 81 81, take away 60, that should be 21. So if I kept going on my pattern here, the 15th number in the pattern is 21. And they could also ask us to figure out the 30th term value. So that's no problem either. 81, take away 4 times 30. 81, take away 4 times 30 is 120. Oh, look at this. Here's where kids get messed up, because for some reason when we think subtract, I guess when they come into grade 7, they think just subtract makes the number get smaller, which is true, but they always switch these around and think that this means 120 minus 81, that has to be 39. Nope, not true. I have 81 and I'm taking away 120. I'm taking away more than I have. So this is going to be a negative answer. Oops. Well, it looks like my screen wanted to zoom in on me, so that's okay. I know that this is going to go below 0. This is going to be a negative number. We learned our integers before. We learned how to do some integer subtraction. This is like a positive 81 taking away a positive 120, if you want to think about it like that, or adding a negative. Long and short of it is, I'm going to be into the negatives, and I'm going to be negative 39. So if I kept going to the 30th number in my pattern, it's going to go negative. Negative 39. It makes sense to me because the numbers continue to decrease, so of course they're going to go into the negative numbers. But this is also something that makes the kids find this difficult to do, that numbers end up getting into negative values. So hopefully that instruction was reasonably easy to follow. If not, rewind it, go back over it again a couple times. I'm going to show you a few other examples. I'm going to get you to try a few yourself, and then I'll show you some solutions for those.